Alright guys, last day of notes over ellipses. We're going to be going over some application problems. So first thing is just practicing plugging in a number. Now in the homework it'll be more like a real life example, but for this I just want to make sure that you know if you have an equation, sometimes it'll want you to plug in an x or a y value and then solve for the missing piece. So we're just going to practice that first. So it says if x is equal to 4, find y. So we're just going to plug in 4 here for x and then solve for y. And all this is algebra. Okay, so go ahead and change this to 16 over 40 plus y squared over 24 equals 1. I went ahead and subtracted and that gives me y squared over 24 equals, so this would be like 40 over 40 if I change that 1. So then when I subtract, I get 24 over 40. Okay, and then you can either do the cross multiplying thing here, so you can multiply here, which is one way of doing it, or you could just multiply by that 24 and get the y squared by itself. Either way works here. So if you cross multiply, you'd have 40 y squared equals, and then it'd be 24 times 24, so 576. Go ahead and divide by 40. And I just simplified that fraction, and then you can take the square root of both sides. I did go ahead and leave it as a decimal. Remember also that when you take the square root, you need to include plus or minus. In this case, it does make sense that you'd have two values, because if you're graphing this thing, it's centered at the origin, right? So whatever it looks like, if you're finding x equals 4, say that's right here, you are going to have two different values for that. So y is equal to plus or minus 3.79. Okay. And then same type of thing. Now it gives us a y value. So if y is equal to 2, go ahead and find x. So same strategy here. So I'm plugging in the 2 for y. So I'll get x squared over 40 plus 2 squared, so 4 over 24 equals 1. I'm going to go ahead and subtract my fraction. Over here, so I have x squared over 40 equals, again I can go ahead and change that to 24 over 24, subtract the 4, which would give me 20 over 24, and then I can go ahead and do the cross multiplying thing. So, sorry, this is all over the place here. That would give me 24x squared equals, and then I would do the 20 times the 40, which would give me 800. Divide by 24. So just simplify that, and then take the square root. So x equals, again, two answers, plus or minus. I can go ahead and just change this to a decimal, 5.77. With these word problems, it's usually going to make more sense to have your answer as a decimal. Okay, next one. An arch has the shape of half an ellipse. The equation of the ellipse is, and then it gives your equation, where x and y are in meters. How high is the center of the arch, and how wide is the arch across the bottom? So first, notice that this equation is not set up how we're used to with ellipses. We want them to be set equal to 1. So our first step here is to divide everything by that 12,544 to get the right side equal to 1. So when I do that and I simplify my numbers here, I'll have x squared over, this ends up being 196, plus y squared over, it ends up being 64, is equal to 1. And now I know what I'm doing as far as graphing this thing, right? The center is going to be at 0, 0, and then you want to think about how far left and right, up and down you would move, okay? you always look under the x squared to tell you left or right. You take the square root of 196, which is 14. So I can usually kind of rewrite it like that. That's how far left and right I would move. Square root of 64 is 8. That's how far up and down I would move. Okay, so if you kind of picture drawing this thing, if this is the center, you're going left and right 14 units here. You're going up and down 8 units. It says it's an arch, so we really only care about this upper region right here. But the question is, how high is the center of the arch? So that's this distance right here, which we said was 8. Okay, it said that our units are meters. And then the second part, how wide is the arch across the bottom? So that would be all the way across. So I have 14 left, 14 right, so a total of 28 meters wide. Good. This one is actually from the homework, but I wanted to go through it because there wasn't one really like this in the notes. So I wanted to kind of help you at least set this one up. So it says a one-way road passes under an overpass in the shape of half an ellipse, 15 feet high at the center and 20 feet wide. So if I just draw a picture, and there is a picture in the homework for you, but it's 20 feet across, 15 feet wide. So then this would be a total of 20, meaning that each piece here is going to have to be 10 across. So you've got your arch, your overpass right there. Assuming that a truck is 12 feet wide, what is the tallest truck that can pass under the overpass? So I think that anytime you have a problem like this, first you want to come up with the equation of your ellipse. We always assume that it's just centered at the origin. Don't worry about, adding or subtracting anything to the x and the y. So if I set up my equation, it's going to be x squared over. Now, again, from the center, you're moving left 10 and right 10. So remember, that would be 10 squared that we put underneath the x squared. Plus, this would be y squared over. It would be up and down 15. Even though you're not going down 15, that is still the value that you would use in your equation, okay, is equal to 1. So if you want to change it, that's fine. So x squared over 100 plus y squared over 225 equals 1. Okay, so now we want to think about what the question is asking, okay, dealing with the truck. Couple things here. We know the truck is 12 feet wide, and it also tells us that this is a one-way road, meaning the truck is going to be centered, okay, in the middle of the road. So if you think about drawing like the back of the truck, it's going to be here, centered at the origin, right, driving through that tunnel, okay. So it says that the truck is 12 feet wide. So all the way across here is a total of 12. When I think about plugging in a number, though, plugging in an x value, if this is the point 0, 0, and I want to know how far away is this point, this distance is only 6. And so in this example, I'm going to be using x equals 6. The question is, what is the tallest truck that can pass under the overpass? The issue you're going to have is these corners up here. We need to make sure that this corner is inside the ellipse and not touching or on the outside, because then obviously it cannot fit through the overpass. So you just, in this example, need to plug in x equals 6, solve for y. That's going to give you the value on the ellipse. So then you would just need to make sure that the height of the truck would be less than whatever value you find. Okay. There may be other examples where they give you the width and the height of the truck and they say, does it fit through the overpass? In that example, you would plug in that value for x and y and see, does it give you an answer that's less than or equal to 1? In that case, if it's less than 1, it will fit in the overpass. If it's equal to 1 or greater than 1, it would not fit in the overpass. Okay. So here is how you would set this one up. Again, plug in x equals 6, solve for y. That would be your height. You would just need the truck to be less than that height to fit through the overpass. So if you're good with those, that's all the new part of the notes. You can go ahead and stop and work on your homework. These next three were really just some review problems that I'll go ahead and go over. Okay. So these were coming up with the equations first and then graphing it. All right. So for this one, it says that the minor axis has a length of 4, and you've got foci at negative 5, 0 and positive 5, 0. So right there, that tells me that C is equal to 5. It also tells me that the center is at 0, 0, because I know it's got to be right in the middle of the foci. When they're talking about the minor axis, that's always tells me what B is. If the total length is 4, that means that B is half of that, which is 2. I can also go ahead and graph where that's going to be because I know that the foci are always on the major axis. So in this case, the minor axis will have to be the y-axis. A total length of 4 would give me, going up and down 2 units. So with this one, I'm going to have to find A in order to graph this thing and come up with the equation. And so remember, I always use A squared minus B squared equals C squared to solve for my missing piece here. So I'll have A squared minus 2 squared equals 5 squared. Go ahead and add the 4. Whoops, jumping ahead of myself here. So I get A squared equals 29. So A is equal to the square root of 29. So remember, when I write my equation, I'm going to be using really A squared and B squared underneath my x's and my y's. So I'll have x squared over, in this case, left and right, that's going to be the major axis, so I'm going to be using A, and really I'm going to be using A squared, so it ends up being just 29 when I take the square root of 29 squared. Plus y squared over 2 squared gives me 4, and that's equal to 1. And then when I take the square root of 29, it's a little over 5. So it's just a little bit past where those foci are. And then I can go ahead and graph that thing. Good. Next one, and I want to show you one like this. I don't know if we kind of did one in the application problem, but anytime you see it set up like this, you want to get it set equal to 1 first. So we want to divide by whatever number is over here so that it's set equal to 1. So then I just simplify my numbers here. 4 over 64, that simplifies to 1 over 16. Plus, and then I've got 16 over 64, which simplifies just to 1 over 4. So I have y squared over 4 equals 1. And now this one is pretty simple. The center is at 0, 0. Right? Underneath the x tells us left and right. So we're going to go left and right. Square root of 16 is 4. Up and down, take the square root of 4, that is 2. And there's our graph. Last one is completing the square, so just practicing this one more time. Okay, so remember that you want to take out your GCF. So I'm going to take the 9 out for the x's. That leaves me with x squared plus 4x plus blank. We'll take out the 16 for the y's. So that leaves me with y squared minus 2y plus blank. And then move over that 92 to give me a positive 92 on the right side. Okay. Next is to do the completing the square part. So for the x's, I'll use the 4. So 4 over 2 squared is just 2 squared. So 4. So the 4 is what goes in the blank. Remember, I need to multiply. 9 times the 4 is 36, and that's what gets added to the right side. Same setup here for the y. So negative 2 over 2 squared is negative 1 squared, which is 1. That goes in the blank, and then again I multiply. 1 times 16 is 16. And so on the right-hand side, I'm going to be adding 16. So my next step is to rewrite it here. Remember that I still have the 9 out in front. I can rewrite my trinomial as x plus 2 squared. Remember, I'm using that number there. Plus the y's, I've got the 16 out in front. And I'll have x, or I'm sorry, it's y. Y minus 1 squared. And then equals, when I add all of that together, I get 144. So then my last step here is to divide by the 144 to get it set equal to 1. So this gives me x plus 2 squared over, when I simplify that, I just get 16 on the bottom, plus y minus 1 squared over, again, simplify, I get 9 this time, and then that's equal to 1. So, graphing. The center for this one is going to be at -2, 1. Remember, look at how, or what you're adding and subtracting to the x's and the y's. Put my center there. For left and right, you always look at what's under the x's. So, square root of 16, so left and right, you're going to move 4. And then up and down under the y's, so square root of 9 is 3. So, left and right 4 here, up and down 3. And then, there you go. Awesome. All right, your homework, and it is in your book, but I also posted it on my website so that you can still do this, do all the problems. The answers are there too. The work is not shown, so make sure that you are showing work if you're wanting to get credit for this. Okay, thanks guys.